Using predominantly recycled household materials, a solar water heater has been designed, constructed and tested to develop the maximum efficiency. A typical solar water heating system functions using two segments, a storage tank and a collector. The storage tank is a well-insulated container which stores the circulating water, and the collector, which consists of a long coil copper pipe and aluminium foil, allows the water to flow through. The solar radiation emitted by the sun is absorbed within the collector and travels through the coiled copper pipe. Once the water has passed through the collector and absorbed heat from the copper pipe, it returns to the storage tank via plastic tubing and raises the temperature of the remaining water in the tank. To determine which factors influence the amount of the heat stored in the solar water heater, 3 different variables were tested: the colour of the collectors, whether the heater had a lid, and the light intensity, achieved by testing at different times of the day. Each individual variable was isolated and tested to determine how the variable directly affected the performance of the device. The maximum fluid output temperature of 38.1 degrees Celsius was achieved after 20 minutes had elapsed at 2:20 p.m. when the solar collector was painted black and fitted with a plexiglass lid. This solar water heating system acts as a source of renewable energy and will be applicable to regions where there is sufficient and consistent sunlight. After conducting the first test, in which the temperature of the water passed through both a neutral coloured solar collector box and a black solar collector box, it was evident that the black solar collector box was more efficient, recording a maximum increase of 7 degrees Celsius over 20 minutes in comparison to the results achieved by the neutral coloured collector box. In order to determine the maximum efficiency of the system, I modified the device by fitting a plexiglass lid to the black solar collector box. In light of the results from test 1, and if I wanted to develop the maximum performance of the solar water heater, the black box was a fundamental element of the investigation. This is because black absorbs all light waves as opposed to lighter colours which will reflect the light waves. As hypothesised, by fitting the plexiglass lid, the temperature of the water over a 20-minute period increased 3.9 degrees Celsius in comparison to the results achieved when the system was tested without a lid. This is reflective of heat retention and is relatable to a hot car with the windows wound up. Finally, after conducting the previous tests at 2 p.m. on subsequent days, I decided to test the effect of light intensity achieved when the system was tested for 20 minutes in 5-minute intervals at different times of the day. I chose to test at 9 a.m, 1 p.m. and 4 p.m. because the sun was in the most effective positions at these times. Approximately 2 p.m. is known for being the hottest time of the day, so I thought I would test this theory. That being the case, I hypothesised that the reading achieved at 1:20 p.m. would be the highest reading yet. After performing the test, the results generated found that the final test at 1:20 p.m. did in fact generate the highest water temperature within that particular test. However, it was not the highest water temperature achieved across the entire investigation. The maximum reading of 36.6 was recorded from that test. This is an increase of 12.2 degrees Celsius from the final reading taken at 9:20 a.m. and an increase of 8.3 degrees Celsius from the final reading taken at 4:20 p.m. The reason for this is reflective of the incoming energy or absorption being greater than the outgoing energy or emission. If incoming energy and outgoing energy are equal, equilibrium is reached and the temperature will stabilise. If outgoing energy is greater than incoming energy, the temperature will get colder. Therefore, the surface will continue to rise as long as incoming solar energy is greater than outgoing surface energy. Maximum solar heating occurs around noon each day, but that is not the time at which incoming is balanced by outgoing energy. These two things generally balanced around 2 to 3 p.m, which is why mid-afternoon is known as the hottest time of the day, and why the reading taken at 1 p.m. with 1:20 p.m. with a steady increase of incoming solar energy happening generated the greatest water temperature for that test. In conclusion, in concluding this investigation, to achieve the maximum performance of the solar water heater, it would be necessary to test the system with a black solar collector component fitted with a plexiglass lid between 2 to 3 p.m. on a day where there is an abundant amount of sunlight. A range of variables need consideration, including the outside temperature of the day, cloud coverage, and the exact time of the day test in order to achieve the maximum performance of the device.